Hi, we are looking at today simplifying radicals and then solving quadratics again. This time some of them are more in something similar to like vertex form, or really just whenever you only have an x squared, you don't have the x term. Let's start with simplifying radicals. So when you are simplifying radicals, you are looking for a perfect square, which you can see I have my list over here of my perfect squares from 1 squared, 2 squared, 3 squared, all the way to 10 squared. I need one of these that's a factor of the number inside here. So for 12, I definitely don't want to look at anything that's higher than 12. So looking below 12, 1 goes into every number, so that's not going to be helpful at all. But 4 goes into 12. 4 times 3 is 12. So I rewrite this as the square root of 4 times the square root of 3. The square root of 4 is 2 because 2 squared was 4. So this is 2 radical 3. I'm going to jump around on these a little bit, so I'm going to look at 50 now. A perfect square that goes into 50 would be 25. And 50 is 25 times 2. Square root of 25, let's see, 25 was 5 squared, so that would be 5 radical 2. Or, like on C here, 36 is literally on my list. It was 6 squared. So if I ask for the square root of 36, that is just 6. Okay. That's simplifying. Every answer down here, you'll have to make sure you simplify like that. Let's look at some of these. All of these I see up in this top row, this x squared here. Now this first one stands out to me because it looks like a difference of squares from factoring. Like I noticed that the b is missing and both of those are perfect squares. So I would factor that to x plus 3 and x minus 3. And I would get my two answers of -3 and +3. What we are looking at today is, what if it's not a difference of squares? What if it is missing b, but I can't use that formula? So you're going to isolate the x squared. So in this case, I need to add the 9 to both sides. Then I square root both sides, making sure you are always going to have to do plus or minus your square root. Like that's crucial. If you write the square root, you have to put plus or minus. So the square root of 9, so let's see here. So x squared of 9 is 3. So I'm going to have plus or minus 3. That is the same as saying +3 and -3. So it is the same as these over here. Both methods work. If I'm looking at h, again, I'm going to isolate my x squared, starting with what's on the same side as it, but the furthest away. So I'm going to subtract my 1. I have 8x squared equals 16. Still trying to isolate that x squared, so I divide by 8. I have x squared equals 2. And then to get rid of the x squared now, so that I just have x, I do the square root of both sides. Again, plus or minus. Now, this one, I knew the square root of 9 immediately was 3. The square root of 2, though, is not a perfect square, and there is no number on my perfect square list that goes into it. So I just leave it like that. Again, you can write it as the plus or minus the square root of 2, or you can separate it out as your two separate answers, a positive square root of 2 and a negative square root of 2. They are the same thing, like this or this. I is similar, trying to isolate that x squared. So I'd subtract my 4. Leaves me with -3x squared equals -81. Divide both sides by the -3. So I have x squared equals 27. And then I'd square root both sides. Again, plus or minus the square root of 27. Wasn't a perfect square, so I'm going to check my list. 9 goes into 27, so I'm going to rewrite this is square root of 9 times square root of 3, because that's 9 times 3 to get 27. The square root of 9 is 3, so 3 radical 3 is my answer. J, K, and L are all very similar as well. This time though, you're trying to isolate this whole set of parentheses that are being squared. I'm going to start with K real quick, and then I'll do L as well, and you can go back and do J. Isolating that, I subtract the 9. So now I have the x plus 4 squared equals 24. Now I need to square root so that I can get to just my x plus 4. So I have plus or minus the square root of 24, which I will simplify. Let's see, 24 is 4 times 6, so that's 2 radical 6. And then when I subtract my 4 over, I have negative 4 plus or minus 2 radical 6. Last one I'm going to look at here is L, similar to K. You're trying to get this squared part by itself, so I have to start by adding the 3. Divide by the 2, so that now everything on this side is being squared. So to get rid of that squared part, I will square root both sides. So I'll have 3x minus 1 equals plus or minus the square root of 20, which simplifies. So let's see, 20 is 4 times 5, so that's plus or minus 2 radical 5. I add my 1 over, and similar to when I added or subtracted that 4 over here, they don't actually get to go together. I'm just going to have 1 plus or minus 2 radical 5. And then when I divide by 3, it literally just stays as 1 plus or minus 2 radical 5 divided by 3. None of that simplifies.